It's all readable? Probably not. I'm going to get a stool just because I'm going to be at the computer the whole time and I don't really want to sit for 30 minutes. If you don't mind. I can start talking, which is that I'm going to talk about Groovy and Gradle. Gradle being the build system that Android uses nowadays, and just my recent explorations into it. Let's see. I also kind of wanted to just try screencasting this, or not screencasting it, just screen recording just for my own purposes. So we'll see if this crashes anything. It probably won't. All right. So that's not what I meant to open. Let's make this visible to everyone. And then I need to bring up my notes, which I have on another computer, because I realize I can't really do a live coding report and also not show you the notes at the same time. All right, so here's my experience with Gradle for the last year. I've been doing Android Studio and Gradle for about a year and a half, and so I've been using it quite a bit and have somehow gotten by. And that's because the Gradle syntax with regards to the basic Android plugin is pretty deceivingly simple. So if you look at this, you can kind of understand what's going on in every line. Like, maybe you don't understand what build script is, but fine, you see apply plugin, that sort of makes sense. You see this Android block, and it looks something kind of like JSON, not really, but you can kind of get a feel for that, and that's how I operated for a long time. And the only issue with that is that I don't, let's see here, I would get to snippets like this, which I'll zoom in a little bit, but it doesn't really matter if you don't read this as much, and be like, what the hell is that? Because this is also Gradle, and this looks nothing like this nice little simple build file here. And I had no idea how people went from that simple build file to writing stuff like this. So like this script, for example, place services, like if you do Android, you probably know about the dex method count limit, where if you go over 65,000 methods, your APK just won't build. And so Google Play Services used to take up something like 20,000 of those methods, so a third of your methods. They split it up now, thankfully. But before that, we had all these scripts for like splitting out the parts of Play Services that we weren't using, because it was already pretty well split apart in the package names. And this script here, these 50 lines, basically strips that out. And that's really cool, but I had no idea how to write it. And for some reason, I didn't have any interest in learning until about a month ago, where I jumped in, and now all of a sudden, I feel like I have the power of the build system at my hands, which is really cool. So I kind of wanted to share that with you, and so take in mind that this is still kind of a beginner's view of Groovy and Gradle, so I'm probably going to get something wrong here. So if someone's an absolute expert, they can correct me on that. But I just, I'm a beginner, but I started a month ago, so I'd like to get you guys started now, and then we can all be awesome at it a few months from now. So in order to learn how to work with Gradle, you actually have to understand Groovy. And Groovy is the language that underlies Gradle. Groovy is a JVM language, so it compiles down to JVM bytecode. You can use other jars with it if you want, but it's not quite Java. It's like Java with a whole bunch of other stuff in it. And in particular, it's much more of a dynamic language like Ruby or Python, so it's more scripting-like. So for the first part of this presentation, I'm going to bring you into the world of Groovy and how it works. And in particular, there's this cool Ruby console, which is something like a REPL, but not quite, that I can use to show you some code. Let's see, can I make this font any larger? No. Can people read this?
Yeah.
All right, cool. So let's start with something really simple that I think everyone will probably recognize. And that's brilliant. I now know Groovy. So the one major difference from Java here is that I can run this without all of that crazy garbage of static class, main, string, args, and all that things. So that's pretty cool. Oh, whoops, I gave away the trick already. So the first trick is you don't actually need semicolons in Groovy. Except in some rare circumstances, some rare corner cases, but for the most part, it's idiomatic not to use semicolons, because they're just we don't like them, so we got rid of them. You can use them, but you don't need them. You also don't need parentheses for your method calls. So this is just as legal as well, and it still works. They also import a whole bunch of the standard library for you automatically. So I don't actually need any of that either. And if I really want to go crazy, I can actually use single quotes for this string too. So this is much more like what Groovy actually looks like when you do it in practice. And so that's why when you are taking the step from Java, you might think Groovy doesn't look anything like Java, but it's really just Java with all of these different rules. This is like 3 different rules applied to it that Groovy can do that Java can't do. So let's look into how we do variables with this. You can do your normal variables. So let's see here. And again, this just works fine. So that's all good. Now for another big difference between Java and Groovy. Groovy can do dynamic typing. So instead of defining string, I can just say def instead. And this works just fine, because it infers the type from the equal sign, the single quotes and all that junk. Personally, I love type checking because it kind of saves my ass for myself. So I don't really like the dynamic part of it, but it's worth knowing because you're going to see defs all over the place in Groovy and Gradle code. If you want to go a step further, you can even actually get rid of the def altogether, and it still works. And this does something really weird though, and I really try to avoid this because what this does is it pretty much leaks it into like the global context. So this is why this isn't quite a REPL, because I can actually still print this out, even though the first line is commented, because now phrase 2 is in this like global context here. If I go back to my phrase, I'll get an exception, because I was actually defining that in a reasonable manner, like humans should do. All right. Another thing I wanted to point out while I have this, so I mentioned that you can use single quotes instead of double quotes. I really hate it when languages just add arbitrary stuff, but this isn't arbitrary. There is actually a difference between the two. So suppose I am printing out hello and then a name. So this would be kind of how you do it normally. And that works as we expected. But in Groovy, there's actually string interpolation that you can do in line. So normally you'd use string.format and then all of these parameters. You can actually just refer to these things straight up. As long as you have double quotes and you're using the $sign. And if you're using single quotes, this won't work. So if I go back to single quotes, it'll actually print out exactly what I have written there. And you can even take this a step further. You can call any sort of method in here. So if I put the brackets here, it's saying I'm no longer even just referring to a variable, I'm referring to a method in it. So I can call capitalize. Ta-da! And so, in general, what I try to do with Groovy is that if I know the string doesn't have string interpolation, I use single quotes. Because that really implies then, like, it just helps my eyes tell this string is not going to change. Whereas if I'm using double quotes, that means, okay, I got to look for the $sign somewhere in that quote. Something weird's going on with it. You can define classes the same way you can in normal Java. So I wanted to show one interesting aspect of classes that you can define. So I'm creating my class, I'm instantiating an instance of it. Alright, this does everything we expected. So one of the things that Groovy does is it automatically adds getters and setters. So while it looks like I'm accessing my var directly, I'm actually getting to it through a getter and setter. So I can use this instead, and this code will work just as well. Set my var, I don't need a space, and get my var. So it's automatically creating those setters and getters. I have to have the parentheses here in this method because otherwise it's going to try to look for a variable called getMyVar, and it won't find it. The cool thing about all of this is that you can still override these. So you can have like string, and then I can return whatever I want. And then when I run this, it'll actually print out goodbye, even though I'm referring to instance.myvar. So again, this is something that you see a lot in Groovy, is people calling getters and setters without actually calling get or using the words get or set. And so you'll see this code like instance.myvar.someothervar.thirdvar, and it's not just that everybody has public properties set on everything. They're actually just using getters the whole way through. What else is there? Let's go to closures, because that's the really interesting thing with Groovy. So let's write a simple method, and this will square a number. So this is how I'd write it if it was in normal Java. And I can just type in square 5. Right, I'm going to do the parentheses. Still trying to train myself the idiomatic stuff. So pretty simple here. You can do, like I said, you can do the normal, you can get rid of the types. It still should work here. Another thing that Groovy got rid of because they didn't feel it was necessary is return statements. So again, like it'll just assume that the last line is returning something. How nice. Now let's turn this into a closure and see how different this looks. Bam, it still works. So this is syntax that seems kind of similar to the Lambda syntax that you might know if you've been working with Java 8 at all. Technically, this is closure square, although almost no one seems to be using the actual closure type whenever I look at code. It kind of bothers me a little bit. They all use def instead. So this is pretty cool because you can define this method inline and basically pass it around to different classes. So, and another thing that happens here is, you can have a type on this. You can have multiple different parameters. Or you can have no parameters, and there's an assumed variable called it, which is the first one. So if you ever see a closure with no parameters and it, that's there. And in fact, the only way to define a closure with no parameters is to do this, at which point this will crash, because it'll say that it can't find a square that takes no parameters. Let's see what's next. Okay, so let's compare this to what is the difference between a closure and a non-closure. So if I have string x equals hello. All right, so these are two different ways of defining what essentially looks like the same thing. If I call closure, this works just fine. I can actually grab this x that I defined outside of the closure. But if I call method, I should get an exception, because it doesn't know where x is. And so the difference mainly with closures is scoping, and that the closure can access the scope of its parent. It can actually get access to all of the things defined outside of it, whereas normal methods can't. And there's also another weird thing that closures can do, which is they have this thing called a delegate object. I'm just going to save this somewhere, because I hit Control S like habitually when I code, so that's just like my thing. So I can print out this delegate thing. And again, I could have been calling get class, get name, but I don't have to. And it says, here's my closure, ASDF, because that's apparently what I named the file, and then this run closure that it created at compile time. And so this delegate object is included with all closures. And essentially, if you're going to run any methods that aren't defined in the closure itself, the first thing it checks is for whether that method's in the delegate. So that's not particularly interesting here, but it gets really interesting when you get to Gradle and build files, because a lot of the times they'll have different closures that are accessing delegates that are some actual handler for it and knows what you're dealing with there. That'll make more sense later. It's a little complicated here. One other weird thing with closures is how they interact with method parameters. Suppose I do have a normal method, and it takes a closure as its parameter. And this is going to be the most boring method in the world, because all it's going to do is execute the closure. So now I can call do stuff. All right, and this executes just fine. The really weird thing about closures is that you can put them outside the parentheses, and it works fine too. And that's because this is kind of like a thing that happens very often in Groovy, is that the last method of a parameter will be a configuration closure of some sort. So essentially you're giving a number of parameters, and then on top of that you're like, here's a closure which can execute this arbitrary code inside of this object I've just created, or this method I've just called. So they added this syntax, I think, just to make that a little simpler. You can still have another variable there. So I can have string x, print that. This is going to be totally backwards, but that's fine. You can still get away with stuff like that. And again, because you don't actually need parentheses, if I didn't have that and I didn't have another variable, I could just call it like this. Just have a method with brackets outside of it. which if you've been working in Android a fair amount, this should look really familiar, because that's going to come up all the time. All right, we're almost done with Groovy, the things of Groovy that I've learned that you really need to know in order to understand what the build files are doing. So there's a built-in list and map native to Groovy, which is kind of cool. So if I can define a list, and it's just 1, 2, 3. I don't need to like bother with any of that new array list or a new string, whatever. One thing that it comes along with is they've actually taken the basic like list. Groovy's taken the basic list and added methods to it, along with a bunch of other things, a bunch of other classes. And one of the things they added was .each, for example. And .each is basically like take every element in it and run this closure on it. So now I can say for every element, print it. And again, here I'm using the implicit it, but I could, be doing something like this instead. You can also use maps that are built in. Let's see, A1, B2. And then you can refer to things either by string, if I want to get to it, or I can actually just do map.a. So that's pretty cool as well. The reason I bring up maps is because they are used for method parameters sometimes. So if I have a method that's just print args, and I'm just going to print out the map. Let's take this map above. All right, we're printing that out. That's pretty cool. Again, I don't need the parentheses though. I keep forgetting that. Oh, maybe I do need the parentheses for this one. Interesting. Okay, so I need the parentheses for now. Here's the crazy thing. I don't need this anymore. It still works. And then why don't I need the brackets now? It's because whenever you do named parameters in Groovy, it takes all of those named parameters and shoves it in a map. That's the first parameter of the method. And again, this is kind of weird, because I can have a second variable. And so I can do, this map has 2 items in it, and it still works like this. And then the weirdest thing to me is I can actually take this and put it way up front. And it still works. Because it takes all of the named parameters, shoves it into the map, and then starts parsing the rest of the method parameters. So that's all of the weird stuff with Groovy that's different from Java. Any questions?
Can you do that backwards? Can you put the string at the end and then do the map?
I don't think that'll work, but let's try it.
Okay.
Yep, yeah, because it's looking for a map on the first parameter. So yeah, it's a way to kind of cheat named parameters, because it's not actually named parameters, it's just shoving it into a map. Any other questions about Groovy? All right, cool. I'm going to close this Groovy console then, and we will take a look at our build.gradle file, which hopefully now will be a little more clear about what this is doing. So I wanted to start with this line in particular, the applied plugin line. Let me make this even a little bigger. So before, when I read this line, I would say, oh yeah, it's applying a plugin. That's pretty obvious what it's doing. But actually what's interesting here is we can actually parse what Groovy's doing here. And I was just talking about named method parameters. That's what this is. It's actually calling apply plugin. This is the exact same code. Minus all the like lack of parentheses and the lack of square brackets and all that stuff. So that's pretty cool. I now understand that this is actually just a method invocation. But where is that method coming from? Where did apply come from? And it turns out that this is what Gradle is, basically. Gradle is a framework which supplies a project object which allows you to do all of these things, which can basically build up a build system. So there's actually this built-in object called project, which is the base, this is the root of all of your build.gradle files. So I can actually type in project.apply, and this code is exactly the same as all the code before. And to prove it to you, let's make this bigger too, so that people can actually read that. This should still work. Yep, it still builds my little sample app. And this build.gradle file is just from something I basically generated with Android Studio a couple days ago. So it's pretty recent, all things said and done. So that's cool. If there's one thing I want you guys to get out of this, it's how to read the documentation. Because what I was so lost on for a long time with Gradle is I knew what options were available if it was already in the source code. I had no idea what I could do beyond that. And so I want to kind of explain how you actually get to the documentation from this. So I want to know exactly what apply does. Like, what can I do with apply? So in order to do that, you want to look up something called the Gradle DSL. And this is, the DSL stands for Domain Specific Language. And I can make this bigger as well. And this Gradle DSL, oh, they don't do that very well, do they? This has all the references to all the types, and in particular this core type project. So I can go look at this project object, and now I can see that it has a bunch of, well, it has a lot of documentation that has properties and methods and things like that. If I search for apply, I can actually find my apply down here. It's apply with options, and if I look at this, it's an apply with the first argument being a map. And then it says applies a plugin or script or using the given options provided as a map. So I've tracked down exactly what's actually happening in the Gradle Build script. And I can look here, the following options are available from plugin and to. So it's cool because it's like I was using plugin, but I could have been using from. And actually I've used from before because if I want to apply a plugin that's not from like say Maven Central, if I want to apply one that's just a local in another Gradle file, I can use from instead. So that's really awesome because now I actually know how to get to things in the documentation. If it's in the root here and there's nothing else, there's like no dots or anything calling into it, you know it's in the project area. So let's take this example and try breaking down some other part of this. So let's break down what build script is. So there's this build script block, and inside of it is a repositories and dependencies block. So again, we can look inside of our project DSL, look for build script, and bam, configures the build script class path for this project. So what you kind of have to know is that Gradle builds, when you want to apply plugins, you have to define it in a class path configuration. And it looks, if you look here, it says this given closure is executed against this project script handler. In other words, there's a delegate object going on here. So when you execute the closure, it's delegating to this thing called script handler, of which now you can click on that and you can actually see, here's an interface, and it's got two methods. One of them is dependencies at the top, one of them is repositories at the bottom, and each of them take a closure for configuration. So again, if we look back at our Gradle build script, ta-da, there's repositories and dependencies. It's no longer this magical phrasing that's out there, it's actually something you can look up. And you can look at all these other things you could possibly do with the script handler. And if you actually go to one of these, say let's go to repositories, configures the repositories, delegates to this thing called a repository handler. You go into the repository handler, and you can see there's my JSONer method that's being called. So again, it just lets me really glide through and figure out what's going on with all this stuff. Dependencies is also another interesting. Dependencies is an interesting one because it uses this thing called dependency handler. And unlike everything else where I showed you there's actual words for it, there's no actual class path method in dependency handler. Dependency handler is really weird in that it configures configuration names. But it's, that's in the documentation, it's telling you all about that. So then let's go down to here's repositories. You can actually look in the project DSL documentation again and see that repositories block also exists as a top level thing. And again, it's the same repository handler, so you can look for the documentation on that. Same with dependencies down here. What's interesting here is that, there's two different ways it calls adds compile dependencies. One is the string, and one is this file tree. And again, if you look in the dependency handler, it explains that there are these different methods. It explains that one of them can be a notation using this kind of string notation here, or some of them can just be arbitrary files as dependencies. So the string notation is fine. Where is file tree coming from? Well, it's coming from project because there's nothing else above it, and it's not in the dependency handler. And again, I can see here that there is a file tree that takes arguments, a map of arguments, and that's what's being configured here. File tree with dir and lim. So you could actually, this code actually works just as well to put project in front of it because that's where the method's actually being invoked. So I was super excited at this point, but then I got to the point where I was trying to figure out, all right, what is the Android plugin actually doing? Where do I find all this information? And unfortunately, this information is not available online in a HTML format. You have to download a zip and then like unzip it yourself. And there's parts of it missing, which are a little bit saddening. But I will throw up a link to that at the end. But you can eventually, we'll get something a lot like this. And again, this looks very similar to the stuff before, except for that the Android tools team generated this. So here again, I can look into what's going on here. The DSL types. I'm just going to click on base extension because that's the first one. And here it explains that base extension is never used. It's actually just applied to app extension or library extension. That explains why if you want to make a library project, it's slightly different syntax than making an application project. So if I click on app extension, I can see all of my favorite friends here. You can see that these are required. Build tools version and compile SDK version are required, or it won't work. And there it is at the top. Compile SDK version and build tools version. Default config, I can look up for what default config is in here. A default config shared by all flavors. I can go into the product flavor and look at all the properties that it has. And here it's cool because it's like, all right, I had these these things defined, application ID, min SDK version, target SDK version, but there's a bunch of other variables here now that I realize I could configure if I really wanted to. Like I could have the test application be a different package ID from the main application. I didn't know they could do that, but you can. So you can kind of dig through the documentation, starting usually at app extension or library extension, checking out what all these different options are and just seeing what's possible, what's available. So this was like the big revelation to me, is I can actually look through this and find out how to configure things. So, any questions about that part of it? Alright, so the third part is the most exciting part for me, which is actually hooking into the build system. So up to this point, we're taking existing API that people have written and configuring it to make our build work. How do I actually make Gradle work for me and do something that no one intended for me to do with it? So in order to do that, I have to first explain a little bit of how Gradle's structure works. Gradle is actually built up of a series of tasks. So if I open up this, I can call this command Gradle Tasks, and it shows me a bunch of the tasks that are runnable on this particular Gradle project. And you can actually see that tasks is a task. So what's happening when I type Gradle space whatever is it's actually targeting a particular task to run. You can see up here that there's assemble, debug, assemble, release. So these are all the tasks that you're usually using in order to build your Android application. And tasks are basically the unit of work in Gradle land. And the thing about tasks is that you can set them up, have them execute, and then have them depend on each other. So you can create a directed acyclic graph of the tasks so that as you need different things to have executed before you, you can execute after them. So that's when you run something like a Gradle assemble debug, you'll actually see this long list of tasks. So it's showing you all the different tasks that are run and in what order they're run. And there's actually, you can see up to date on a lot of that because Gradle can cache, is smart enough to know when things don't need to be run again. So let's write our own task. We don't actually even have to hook into our build system. We can just write our own task just out of nowhere. Let's hit to 2. So here's a simple task. Again, task is a method in project, and it creates a task that's named this variable. That's named this. Then I'm giving it this configuration closure. In that configuration closure, I'm calling a method called doLast. Now that's part of the task, saying I want to do this. When the task runs, this is the last thing it should do. And I can actually use doLast. I can use doFirst. I can call multiple things. So I can do last this and do last something else. So now if I call Gradle hello, there. So it says it executes app hello, my app hello task, and then it says hello world. So that's pretty cool. There's an alternative syntax you can use that you might see on occasion. This confused the living daylights out of me for a bit, because it's super duper hard to Google for syntax like 2 brackets. This does the same as doLast. Just because why not? Yeah, I don't know. Shortcuts, but it's super hard to Google, so it made me unhappy for a bit. Let's create a second task and make it depend on the first. So if I make this second task, so right now if I call Gradle respond, it's going to just print that out. All right, goodbye. Now if I say depends on, and I execute respond, it recalculates the graph and it actually runs hello before it runs goodbye. Yay! So we've got a tree. We've got a tree of dependencies now. And the really cool thing, like, so this seems like it's kind of a constructor that has a depends on. I can actually execute that later. So I can take if I can find a task, I can hook into it and say, by the way, you thought you were going to build, but actually you need to do my stuff first. So before I can go to the next tab to actually hook in, there's one really important thing to understand about how Gradle works, which is that Gradle has a two-step build process. The first step, it configures all the tasks that are going to run. The second step, it actually runs them all. So, for example, if I take this out, or if you see it, if I put the do last back in, and then I put print line configuration, this is it. If I call hello again, this weird thing happens. It prints configuration before it says my task ran. And that's because it's executing that first print line configuration during the configuration phase. Then once it's figured out the whole graph, then it executes do last. So you can actually, again, if I call respond, it'll do the same thing because configuration is happening in the configuration phase. It doesn't really matter which order. And in fact, I can put this over here. And make this really ugly. And again, even though I'm calling respond, which depends on hello, it still prints out configuration first because that's happening during the configuration step. And if I use Gradle-M, which is just a dry run, all it does is configure the tasks and tell you which ones are going to run in order. It still prints it out. So the key takeaway here is that when you set up your tasks, they have to be set up at essentially the right time. You can't have like dynamically start adding tasks after the tasks start executing. So if I want to hook into an actual Google build, what am I going to do? What do I do if I want to say on every single build, call respond and hello? So this is going to be a little hand wavy here because I've read through the documentation and you haven't. But there's essentially, like, you can create this, you can call Android application variance. And no one say anything yet, because this is wrong. All right, so the application variance is an array of all the variants of your project. And a variant is essentially a combination of your product flavor and your build types. So at the moment I only have two, because I have a debug release, and I have a debug version and a release version. So it should print out that I have two different variants. But if I run this right now, as a dry run, it doesn't print out anything. And that's because there's this timing issue that's coming into play, which is that Android itself hasn't configured itself. Android doesn't actually know about the application variance yet. It hasn't evaluated itself fully. So what I'm going to use here instead is .all. And .all is something that Gradle, I think, added. I don't think it's based Groovy, where essentially it says, take this list, and if anything is ever added to the list, execute the closure on it. So .each executes a closure on everything in the list the moment it's called. .all does it whenever it gets called. So if I run this dry run again, I should print out, yep, debug and release. So that's pretty cool. I've got an access to the variant. And if you look into the actual source code of what the variant is, or if you look at the documentation, which is, this is actually where the documentation falls over, because for some reason this one particular thing, which is really important, is missing. There's all, like, the variant has all sorts of information. It has the name, but it also has where it's getting its inputs from, where it's putting its output files, but more importantly, what all of its tasks are, like the task that zips it, the task that assembles it, the task that compiles it. So I can actually take variant.assemble, and I can use my depends on here. So now what will happen is something very interesting. If I call assemble debug, scroll up, you can see that my task got run before it. If I call assemble release, you'll still see the same thing. Now, I'm not exactly sure why it chose a different order to execute things in, but it's determining the graph, so hopefully it's not going to happen out of order as long as the depends are in the right order. And then if you call assemble, it'll still, because it's assembling both debug and release, it'll still only call this dependency once because it assumes that every task only really needs to be run once. So this is super duper cool and code that you should use because it's awesome. Because it basically lets you write your own tasks that do anything you want them to do, and then it'll automatically execute on every single build that you run. So that's how you hook in a nutshell. What you do from there depends on how much more Groovy and Gradle that you learn. And that's about it.
I was going to say flavors are absolutely awesome. When I was working with one of our projects, someone had written a multi-page ants script to build everything, and I managed to boil it down to exactly 3 lines of Groovy because all we needed were flavors with the build config settings.
Yeah, I've actually been spending the last week on a really fun project where I'm automatically building SVG resources into PNGs and then putting them in your build directory. So it doesn't pollute your source code, and you can use SVGs as drawings, which is pretty cool. And that would not be possible without knowing a thing or two about Groovy.
Yeah. Crazy bit of trivia, because Groovy is a JVM language, you can actually write Android apps in it. So what big name company actually is bragging about having written their Android app in React with Groovy?
All right. I mean, yeah, that's cool. The only thing that really bothers me about Groovy is the dynamic typing.
Oh yeah.
And I would feel so sad. There's also some weird things that they've just left out of the library. For example, I found a bug that's almost 10 years old that was like, sometimes private doesn't work. And
because of the dynamicness of it, they've just not cared.
They just don't care.
It's really nice for certain things, but yeah, if you're coming from Java, it's scary.
it's very scary. I think the reason they haven't fixed it for so long is because so many people use that for testing.
Yeah.
So I don't have to worry about this mock-edo thing anymore. I can just access everything directly.
If you really care, there's AST transformations, package ones at least, that you can use, and there's ways to force things.
I don't know if I care that much though.
So
It's more that I miss the compile time checks because I'm afraid of my own mistakes.
you can use compile static then.
Does that work for all the checks then, even the stuff in evaluates? I should use that then.
I don't know.
Because I think I remember reading about that, and they were like, it sort of maybe works sometimes.
Yeah.
Because you can still write code that doesn't actually have all the types in it, and then there's nothing it can really do about that. Because you can have a method, you can have a closure that could take one of 3 different types of parameters here.
Yeah.
Because it's calling some other closure.
When I was using compile static, if I used def, it would actually complain because it would be like, oh, this is an object, it can't be a string and stuff like that. So you have to chorus it. There's also a type check, AST also, if you really want it.
I'll check those out, thanks.
So yeah, it was actually the New York Times. They built their app on React Groovy and made a big deal about it. So it said it saved them a lot of work, and they made a whole blog post about how they. But I don't know. It kind of scares me, some of the things you showed us. So I don't know.
Yeah, I'm hoping Kotlin comes in and starts supporting annotation processing, and then we can use it instead.
I like that.
Because it has some of the cool things that you can do in Groovy, but it's a lot safer.
Yeah.
I have a dumb question, speaking of very scary things. So how would it fail if you said hello depends on respond and respond depends on hello?
I don't know. Let's find out.
Well, I'm just picturing I'm going to write 40 tasks, and then someone's not going to be paying attention and be like, oh, we'll just make it so that happens first, and introduce a cyclical dependency.
There we
I
go.
know it'll fail. I just want to see how well.
That is how it fails.
It's like, oh, cyclical dependency, you figured it out.
Awesome. That's right.
Way in the back.
Yeah, you mentioned the dex limit earlier. I actually used, well, this is all wizardry to me still, but I actually found a pretty good gist for stripping out the Play Store, Play Services, all the useless stuff using Gradle. So.
But that was the code I was showing you at the very beginning, actually.
Oh,
that was it, like demarcados.
It's also easy to use multi-decks now.
Sort of. Sort of. There's a big problem.
Play services still. The compile time takes longer if you don't do that.
And the other issue is that
7 seconds long.
my understanding is that pre-lollipop multi-decks works, but it freezes your entire class loader until it loads everything. So your app startup time is like ballooned like mad just getting multi-decks to work.
So what's the most useful thing in your month of actually working with it and creating your own stuff?
That SVG plugin I was talking about. Because that was something design wanted, because they were already working in SVGs, and they were just like, this feels like a needless process for us to take these SVGs and then automatically cut the asses for you manually. So we're just trying to figure out what the best automatic solution was. And there's a bunch of solutions out there for converting it in a multi-step process, where you basically you can either use some sort of Python script, or it's a Gradle task, but it's not a task that's run every single time. But with all this stuff I've learned, I've actually figured out how to make it it just automatically compiles the SVG into your resources without having to be told to do so. It just happens during the assembly step, which is really cool.
So this is something I ran into. I don't know if anyone else has run into this, but if you have, in my situation, I'm building my main app, but I'm also building, a library, another component at the same time. And if you build, let's say, assemble debug on the one, it builds all the flavors of the dependency. So it automatically builds debug and release, which of course I don't want. I just want the debug version also of my service, for example. Has anyone run into that?
No, you can. One of the great things about the way the tasks work is they all depend upon each other. So if you say Gradle assemble, it's actually building every single task in your app. But you can say Gradle assemble my flavor 2, my flavor 3, debug, and be very specific and build only what you want. So if you say Gradle assemble debug, it only builds every debug version, every debug type, because they use the word type. And you can use every flavor dimension as well.
Right, but this is another separate library.
Yeah, I know what you're talking about.
You can't give a flavor matrix and then have it apply that same matrix variance to the other things. It just builds everything of your dependencies, which is supposedly an existing bug, and I don't know if anyone's gotten around it yet.
I don't know. I haven't really looked into it. Because after the first build, it doesn't really matter because all of that will then be cached, hopefully. By the way, one cool trick that I also learned is that if you're using Crash Linux or Fabric or any of that stuff, there's a boolean you can set that causes it not to be run on debug on any given build flavor. And the way that Crash Linux works with their injection, it actually ends up having you reprocess all of your resources every single time you assemble, which takes up a lot of extra time. So I've disabled it all on debug builds, which means that now my debug builds take 8 seconds less. It's pretty cool. So I can try to look up where that is. I don't have it in anywhere except for my actual build files, so. Secrets. No, that's not it. This thing is kind of a mess. Don't make fun of me. Or maybe it's not in this right now. Oh shoot, I'm on the wrong branch. Whatever. If you want to know, I'll look it up later and tell you. Okay, that'd be great. Yeah. Anyways, if there's nothing else, I'll move out of the way. Cool.
Gradle's a perfect segue into some of the stuff I'm going to talk about.
Awesome. So now you're a Gradle master, so you can absorb all of this.
So while I'm setting up, trivia question: what the strings on Groovy with the double